In this video, we are going to do some 7 questions from the chapter quadrilateral, that is for class 9th, which are based on these two property. That is, one is called midpoint property and other is the converse of midpoint. So let's start with the first question. In the first question, it says in a triangle ABC, D and E are the points on side AB and AC. Given that AD is 3.5, A is 4 centimeter, D is 2.5, we have to find the perimeter of triangle ABC. So let's say if I take a triangle ABC and I name this as say ABC. Further, it's given that D is the midpoint of, we have D as the midpoint of AB, right? And E is the midpoint of AC. And what we have to find out is the perimeter of triangle ABC. So first thing that we'll do is to join this length DE here. So I join this length DE. And I'm writing the measurements which is given here. You can figure out that the measurements given here is for AD. AD is 3.5. This is AD, which is 3.5 centimeter. AE is given as 4 centimeter. And further, we have the length of DE as 2.5 centimeter. And what we have to get the perimeter of this triangle. So what we know that perimeter of a triangle, let's say if I talk about the perimeter of the triangle ABC here, right? We have to get the perimeter of ABC. So perimeter of a triangle is sum of its sides. So we can say it should be the length of AB plus BC plus AC. Now figure out that we are given the D as the midpoint of AB. And as you can see that since it is midpoint, then AD and BD are equal. So this is also 3.5 and EC is also 4 centimeter because this is the midpoint. Now, what we are going to do is to apply this property here that the line joining the midpoint of two sides of a triangle is parallel to the third side and half the third side. So check for this part only, half the third side. That means the length of DE is half of BC. So I can therefore say that the length of BC will be twice of this using the property of midpoint theorem, or say theorem. Midpoint theorem says that if a line is drawn joining the midpoint of two sides, then it is half the third side. So I can say the length of BC will be how much? 5 centimeter. Now from here we can get the perimeter AB, which is, I can see that is 3.5 plus 3.5, that is 7. BC, which is 4 plus 4, that is 8. And AC, that's AC. Okay, I took the wrong order. That's okay. BC is how much? 5. And AC is 4 plus 4, that is 8. So perimeter comes out to be, this is how much? 15 plus 5, that is 20 centimeter. Yeah, let's move to the next. In the second question, it says in a triangle ABC, AD is the median through A and E is the midpoint of AD. So let's say first I'll draw a triangle here. And I'll name this triangle as ABC. Further, we are given that AD is a median. So what is a median? Is a line joining the midpoint of a side with its opposite vertex. So this is what going to be the median here, that is AD. One more time, median is a line joined from the midpoint of a side with its opposite vertex. Now further, what does it say is that E is the midpoint of the median AD. So I have to take the midpoint, right? I'll take a midpoint of AD and say I name this as E. So here these two are equal, right? AE is equal to AD. Further, it says that BE, that means BE is joined and it is produced to meet point F. So I'll join BE first, start with B, join with to E and produce it so that it meets the line AC at point F, right? So we have used all the information we had here And now check what we have to prove here is AF is equal to 1/3 of AC. This AF is 1/3 of AC. I'll show it again. This AF is 1/3 of AC is what we have to prove. So for that, we are going to make it 3 equal division here. Okay. There's a one construction here, and the construction is what? Through point D, we'll be drawing a line, right? Through D, I'm going to draw a line. As you can see, through D, I'm drawing a line parallel to BF, right? Through D, I have drawn a line, as you can see, parallel to BF. And say I name this as H, or say G, this point as G. Now check, if I prove AF is equal to FG, and if I prove FG is equal to GC, so we can say that AF is 1/3 of AC. So this is what I'm going to do in this question, that first I'll be proving first AF is equal to FG. And this is only possible if I apply this converse of midpoint theorem. And then it says that a line drawn through the midpoint of a side parallel to the other side bisects the third side. So let's figure out how can we apply this property. And before that, we need to mention the triangle, right? I'm going to consider this triangle, right? It should be clear from the figure. I'm going to consider this triangle. So we'll be writing that is in triangle ADG, we have E, right? This is point E. We have E as the midpoint, right? E is given the midpoint of AD, and this is given. And this EF, as you can see, this line EF is drawn parallel to DG, right? This is DG. That's from construction. So let's read this property once again. It says that if a line is drawn through the midpoint of one side of a triangle and is parallel to the other side, then it will bisect the third side. So therefore, we can say from here, therefore, F is the midpoint, right? F is the midpoint of AG, right? Since F is the midpoint of AG, so we can say from here that AF is equal to FG. AF is equal to FG. Now, very same thing we are going to do in another triangle so as to prove the second part. Now, in the next part, I'm going to consider a different triangle. And we need to observe here that we are supposed to prove FG is equal to GC. So we'll be considering this triangle, right? We will be taking this triangle, right? So what you can find here that same way, we'll be considering first the triangle, that is triangle. We have BFC. Here, what you can observe that D is the midpoint, right? D is the midpoint. D is the midpoint of BC, and that is given, right? And as I said in the beginning, that AD is a median, and median is a line joining the midpoint of a side. So we say D is the midpoint of BC, and this is given. And DG is drawn parallel to BF. That's we have already done in construction part, that this line DG, right? You can see from here that line DG is drawn parallel to BF, right? And that's from construction. This is from construction. So applying the property, I can say, applying this property of converse of midpoint, I can say that FG is equal to GC. Am I right? FG is equal to GC. And this you will say, as say, you can mark this as equation 2. So this is 1 and this is equation 2. Now from these two equations, what you conclude? From these two equations, that is from 1 and equation 2, you can see that AF is equal to FG and FG is equal to GC. So that means AF is equal to FG is equal to GC. And hence we will say that statement that AF is one-third of AC. And that's how this question will be done. Now moving to the next question. So in the third question, it says that the diagonals of a quadrilateral ABCD are perpendiculars. So before we read, let's make two line segments perpendicular representing these diagonals. So I'm first making the diagonals, right? This way I can figure out that what kind of quadrilateral it is going to be. Now further, I'm going to join these points. Let's say this is joining these points to make a quadrilateral. Right. And if I name this as A, B, C, D, what is it says that further we have to show that the quadrilateral formed by joining the midpoints of the sides forms a rectangle. That means we need to join the midpoints. Like say I took P as the midpoint of this, Q being the midpoint of this, R as this, and S as this. And this is given perpendicular. I took this point of intersection as O here. Now rest I'm going to join these midpoints, right? And the quadrilateral so obtained by joining is a rectangle. That's what we need to prove. Now to prove this, we are going to use this midpoint theorem here. And the midpoint theorem, as you can see, I've already written the midpoint theorem here. That is the line segment joining the midpoints of the sides of a triangle is parallel to the third side and is half the third side. So in the first go, I'm going to consider this triangle. Let's say I took this triangle. Yeah, I took this triangle. Here, what you can observe that I can write using this property as P is the midpoint of AB and S is the midpoint of AD. So we can say that PS is parallel to BD and this PS will be half of BD. So I mark this equation 1 and will write this property. Now, if you consider the other triangle here, let's say if I talk about this triangle, I'll use different color. Say now I take this triangle, right? I took this triangle that is BCD. Here in this triangle, what you can see that QR is parallel to BD and this is QR is half of BD. And I'll mark this equation 2. Now from check these two equation, you can see that we have same BD here, right? And other side also same half BD. So from here, what you can see that PS is equal to BD and QR is also equal to BD. So from this equation that is 1 and 2, you can say that PS is equal, sorry, first is PS is parallel to QR and PS is equal to QR. So what you know that if same pair of opposite sides of a quadrilateral are equal and parallel, it becomes a parallelogram. So you can now say this figure is a parallelogram. Right. I prove this figure a parallelogram, right? This one as a parallelogram that is PQRS. So I'll be writing therefore PQRS is a parallelogram. Now, once you prove this figure as a parallelogram, you can prove one angle as 90 degree. And if you prove one angle as 90 degree, it becomes a rectangle. So in order to prove that, I'm considering this quadrilateral. Yeah. So the quadrilateral, I can shed it properly so as to figure out I'm talking about this quadrilateral. Check here. Okay, over here, what you can see that I'm taking this point as say M and this as N. Now figure out that here we can write MQ is parallel to ON, and we can also write MO is parallel to QN. And again, from the same reason, that is midpoint theorem, right? You can just write on the same property. So it becomes what? If two pairs of opposite sides are parallel, right? This is being parallel to this is parallel to this, and this is parallel to this. So we can say that it is a parallelogram, right? So we say that MONQ is a parallelogram. Now, if it is a parallelogram, what you know that opposite angles of parallelogram are equal. So now I can say for this figure, the opposite angle, that is this angle, should be equal to this. So I can say that that is angle MQN is equal to angle MON. And the reason for this is what? The reason is opposite angles of parallelogram are equal. Now what you can notice here that this angle is given as 90 degree. This is 90 degree, right? This is 90 degree. So that implies that angle MQN, right? Angle MQN is also 90 degree. So I mark this equation as 3 and this as 4. So now I can say that PQRS is a rectangle. And the reason is a parallelogram whose one angle is 90 degree, right? A parallelogram whose one angle is 90 degree is a rectangle. Now let's move to the next question. This question number 4 out of 7. It says D and DEF are the midpoints of sides AB, BC, and AC of triangle, respectively, of an isosceles triangle ABC. We need to prove that EDF is also an isosceles triangle. So what I'll do here, let's say if I make an isosceles triangle here, and if I name this as ABC, and this is an isosceles triangle where I'll take any of the two sides equal. Let's say I took AB is equal to AC. Further, we are given the midpoints, right? So D, E, and F, these are the midpoints, right, of triangle ABC. And let's say if I join these midpoints, so I join these midpoints, right? So what we need to prove that this triangle is also an isosceles triangle. This is what we need to prove. Now, clearly, we'll be using the midpoint theorem here. What you can say here that the line joining the midpoints, right? So we are given the midpoints of AB, BC, AC respectively. We need to prove that EDF is also an isosceles triangle. Okay, right. So what you can see here that the line joining the midpoint of two sides is parallel to the third side and half the third side. That means here I can see that say that I'll take DF, right? DF, this length DF will be parallel to AC and is half of AC. So DF is half of AC. And using the same property, I can say EF, right? I can say EF as half of AB. And the reason, as I said, is going to be the midpoint theorem. Now check here. We have AB is equal to AC, right? We have AB is equal to AC. That implies that half AB is equal to half AC. So if these two are equal, that means we'll have DF is equal to EF. Now check what we did. I have proved two sides of this triangle equal, therefore it's an isosceles triangle. Therefore, DEF is an isosceles triangle. That much only we have to do. Let's come to the next. The next question, question number 5, it says that prove that the medians bisecting, median, not medians, bisecting the hypotenuse of a right angle triangle is half the hypotenuse. So what I'll do, let's say if I make a right angle triangle first, I made a right angle triangle and I named it as ABC. Clearly B is 90 degree here. And we have to take the midpoint of the hypotenuse. Let's say I took D as the midpoint of the hypotenuse and I'll be joining BD. BD being the median, right? And median is what? Line joining the midpoint of a side with its opposite vertex. Now, what we need to prove here, the to prove part for this question is what? That is BD will be equal to half of AC. That's what we need to prove. Right. For that, we have a construction here, and the construction is we'll be drawing a line, right? We'll be drawing a line, say DM, and that is parallel to BC. Right. Now look into this property called converse of midpoint. It says line drawn through the midpoint of one side parallel to the other side bisects the third side. Right. So now we can apply this property and say that in triangle ABC, well, D is the midpoint of AC, that's given, and BD is drawn parallel to, is it BD? It's not BD, it's DM or, yeah, it's DM is drawn parallel to BC. So applying this converse of midpoint, I can say that M is the midpoint. M is the midpoint of AB. So we got AM is equal to BM. So here we can say that the length AM is equal to BM, right? That's what our concluding point. Now, next, you can also observe that these two lines are drawn parallel. So by using corresponding angle property, I can say these two angles are 90 degree. That means angle AMD should be equal to 90 degree, or say it is equal to angle B, and B is 90, so this is also 90. So if this angle is 90 here, that is AMB, if it is 90, then using linear pair, I can say AMD should be equal to angle AMB. That also is 90. This angle should also be 90, as you know that, applying linear pair. Now, once we have done these two angles as 90 degree, the next thing that we are going to do is to prove these two triangle congruent. Let me show you what triangle I'm talking about. Right. So here I'm going to consider one as this, and say the other triangle here is, say this one, right? In these two triangles, I'm going to prove these two triangle as congruent. So let's see how we can do. So we'll consider the triangle here, that is AMD, and the other triangle as AMD and BMD, right? It is BMD. Check here what we have already done here. We have proved AM is equal to BM, one of its sides equal. We have MD is equal to DM, that's a common side, and 190 degree. And which angles we have proved 90 degree here? That is the angle AMD is equal to BMD, is each 90 degree, right? So here we can say the triangles will be congruent. Now you can say these two triangles will be congruent. That is triangle AMD is congruent to triangle BMD. And that's by side angle side. Once we prove these two triangle congruent, so what I can now say, can I say that this length BD is equal to AD, and that's from CPCT. BD should be equal to AD, right? BD, if I write properly, this is BD is equal to AD. And what you know that D is the midpoint of AC, that means I can say from here that this length BD, I can replace AD with half of AC. As you can see that D is the midpoint of AC, so I can say that I can replace AD, which is half of AC. And I think this is what we needed to prove. Now let's move to the next question. Now we are on the sixth question out of seven. It says A, B, C, D, and EF are three parallel lines intersected by two transversal such that AC is equal to CE. We need to prove BD is equal to DF. So let's say if I first draw three parallel lines, say this is one, this second one, and this being the third. And these two parallel lines are intersected by a transversal. Let's say I make this as the one transversal and this to be the other transversal, right? So the lines, I'm going to write these lines as what? This is, say, I took this point only as A, and this is B. So this has C, and this is D, right? And we have more as E. This is E, and this is F. And as you can see, the transversal, they are named as this is L and this is M. Okay, I write it here. L, M, N are the transversal. Further, we are given that AC is equal to EC. This is given, and we need to prove that BD is equal to what we need, DF. So, yeah, BD is equal to DF is what we have to prove. Now, for that, we are going to do some construction here, and the construction will be joining A with F. Now, we are going to apply the converse of midpoint here, and let's say I took this point of intersection as G. Now, in the first part, I'll be considering this triangle, right? So you just need to focus on this triangle here. So in this triangle, we are going to apply this converse of midpoint. As you can see, let's say if I name it is triangle AEF. What we know that C is the midpoint, right? C is the midpoint of AE. That's midpoint of AC, right? One side. And we can see that CG is parallel to EF. And that is given, right? CG is parallel to EF, then by property, I can say that G is the midpoint, right? Using this property, I can say that G is the midpoint of AF. That should be. So now this is equal to this. Now next we are going to consider another triangle, and the triangle this time I'll consider is this one. Look into this triangle. Now over here, we already have the midpoint of one side given. Let's say I take the triangle here. This time the triangle is what? ABF. We know that G is the from here, right? G is the midpoint of AF, and this line GD is given parallel to AB. That is, GD is parallel to AB. That's given, right? So from here, therefore, we can say applying the same property, that is converse of midpoint, I can say that D is the midpoint of PF. And hence we can say, right? Therefore, I can say that BD is equal to DF. So this is what we needed to prove here. Now we have one more question to do. So we are on 7 on 7. Seventh question, it says ABCD is a quadrilateral and PQRS are the midpoints of these sides ABCD. respectively, and we are given the length of BD as 12 centimeter. We have to find the length of QR and SP. So let's say if I make a quadrilateral, and it's any quadrilateral I can make, like say I make this quadrilateral and I name it as ABCD, irrespective whether it's looking like a trapezium or parallelogram. We just need to make a quadrilateral. And then we have to take the midpoints of these triangle. That means P being the midpoint of AB, Q being the midpoint of BC, and yeah, that's R is the midpoint of this, and S is the midpoint of this. Now, what does it says that if the length of BD, right? Here I need to join BD here. We don't know the length of BD here, right? And what we have to get is the find the length of QR plus SP. So QR is what? I'll join QR. This is QR and this is SP. We have to get the length of QR and SP, right? And there's some, in fact. Well, clearly it is directly based on the midpoint theorem. So let's begin with taking one triangle. Let's say I take this triangle. Here SP is half. Moreover, we know the length of BD. So let me write down BD is how much? 12 centimeter. BD is 12 centimeter. So let's say if I consider the triangle here, that is ABD, I can say that the length of SP is half of BD. Well, we need to mention that P is the midpoint of AB and S is the midpoint of AD. Line joining the midpoint of two side is parallel to the third side and half the third side. So I'm using the half concept, right? And similarly, if I take the other triangle here, this time I'll take this triangle that is BCD, right? So need to mention that in triangle BCD, I can say that RQ will be what? Half of, yeah, this is RQ. Length of RQ is what? Half of BD, right? Using the same property. Well, you should know that we know the length of BD. So half of BD, that is half of 12. So the length of RQ is what? 6 here. And similarly, from here we can say SP is also half of, this is half of BD. Half of BD and BD is what? 12. So SP is also how much? 6. Now check here. We have got the length of these two, and this is what we have to determine. That is QR plus SP. QR is 6. QR plus SP. So QR is 6 and SP is also 6. So that comes out to be 12 centimeter. So this is how this question can be done.